Now, after introducing electrostatic, now we are taking the basic term electric charge. Electric charge, it is basically a basic property of a material which give rise to electric force between various objects. It is a basic property which give rise to electric force between various objects. Now, electric charge, it is denoted by symbol E. For understanding it, first of all, we are coming again to the structure of atom. As we know, in the atom, the positive charge nucleus is there. Electrons are revolving in their orbits around the nucleus. Now, as any atom as a whole is neutral. It is not that the atom will be having either positive charge or negative charge. Any atom, it is always neutral. What is the meaning of neutral? It means same number of electrons and electrons and protons should be present. Electron having negative charge, proton having positive charge. So number of electrons and holes should be equal. Now, electron, that is a negative charge particle. So what will be the value of electronic charge? That is 1.6, that is minus 1.6 10 raised to the power minus 19 coulomb. Proton also have the same charge but with positive. That is E, electron, that is we are taking proton. Proton having charge 1.6 10 raised to the power minus 19 electron. So, when we are taking that outermost electrons of the atom have less force of attraction from the nucleus, it means they have a tendency to to move from the atom, and on rubbing they will be shifting to some another atom. You can term it as a technical term, work function. Work function is an energy given so that electrons can be moved. Electron will acquire sufficient energy so that they can move from there. Now, in the previous example which we have taken, when a balloon is rubbed with the fur or hair, electrons are transferred from fur or hair to the balloon. Initially, both were neutral. This is a main concept. Like, again I am repeating that balloon is taken as a neutral. Number of electrons and holes both are equal. In fur or hair, electrons and holes are equal. Electrons and protons are equal, not holes. Electrons and protons are equal. Now, when balloon is rubbed with the fur, on rubbing, what will happen? That now balloon has a tendency to attract the electron, where fur has a tendency to lose the electron. So due to this, electrons will be shifting from fur to balloon. That's why now the balloon will acquire negative charge and it has a tendency to attract bits of paper. It means loosely bound electrons are shifted from one material to another. So is it clear to everyone? Now we have to come some basic properties of the charges. Like, when glass rod is rubbed with the silk, the glass loses electron and silk cloth gains electron. So when we are like this, we can just relate that we have two buckets, one filled with balls, another is empty. So when we are transferring the balls from one bucket to another, this you can just take the example that how electrons are shifting from one atom to another, like balls are moving from one bucket to another bucket. So now we have introduced that glass rod will acquire positive charge on rubbing with the silk cloth. So two glass rods again acquiring positive charge. Then we are taking two positively charged glass rod and we will try to bring them closer. So what will be there? Positively charged like charges, that will be repulsion force will be existing between them. Again repeating, you can see that when positively charged glass rod is brought near to again another positive charged glass rod, there will be force of repulsion. So it means like charges repel each other. You are familiar with this concept in the junior classes. Likewise, when ebonite rod is there and you are rubbing it with the fur, ebonite rod will acquire negative charge and fur will acquire positive charge. So when this negatively charged ebonite rod is brought closer to another ebonite rod, then both will be repelling each other. Reason being the same as I have already mentioned. So like charges repel each other. Let's take another property, that unlike charges attract each other. So we have to just take same glass rod and ebonite rod glass rod positively charged, ebonite rod negatively charged. When these are brought closer, being oppositely charged, they will attract each other. So here the force of attraction will arise. In the previous case there was force of repulsion. So unlike charges attract each other. Now is it clear to everyone? Now there can be conceptual questions on the basis of it. As we say, the two like charges repel each other, unlike charges attract each other. The question is, can two like charges attract? Initially what we will say, no, they cannot attract. But if one of the charge is very small and another charge is very large in comparison, so the dominance factor is of bigger charge. So that's why if one charge is larger in comparison to other, then only they can attract each other. Point to note that when we are rubbing the bodies, they are insulating bodies. So what is happening? Electrons are transferred only from the rubbed area of the insulating body. That means rubbed area of the insulating bodies get charged, and this charge does not move to another part of the body. It means this is an insulating body. On rubbing, it is acquiring charge at this particular point. So it doesn't mean that it will move to this point. It will stay here. This is the basic property which we are studying. So now recapitulate.